So we're going to practice graphing another polynomial function in this video. So the first thing to do is the end behavior. Now to do that, we need to know the leading term. So we can run the leading coefficient test. So I know I'm going to have a -2 times some kind of x squared, because that's going to be the highest degree there, and then times another x. I mean, that's kind of how you can think about it. I think we maybe showed something earlier about adding the exponents here, but that's what's going to happen. So that leading term is going to be -2x cubed. Now, I can multiply this all out. It wouldn't be that hard, but there's more polynomial to it. I just don't want to multiply it out. Okay, so I'm just being lazy. The leading term tells us end behavior, so we know it's going to go up to the left and down to the right, because this is odd. So we've got some kind of John Travolta thing going on, one up and one down, and it's negative, so it's not the normal way, it's reflected. Okay, so that's what we know. Okay, next, we want to know about the x-intercepts. Now, the great thing about the form that they gave us is we know the x-intercepts, because it's any place that that factor is going to equal 0. So we have intercepts, or you could call them zeros. I've been calling them zeros a lot. We have one at 1, and we have one at -2. Okay, now what's the multiplicity? The multiplicity of 1 comes from right here. So that's got an exponent of 2. The multiplicity is 2. And then from here, the multiplicity is 1. So what's the behavior? Well, at 1, this is the 0. Let me graph it right there. That is the 0. It is going to bounce, okay? Or touch and turn. That's what we've been saying. Touch and turn. Okay, bounce is shorter to right. Okay, what's going to happen here at -2? Again, I can graph that 0. It's right there at -2. There's the 0. And it is at 1, so it's going to simply cross. Okay, so I know the end behavior. I know what's occurring at the zeros and how the graph's going to go. Now I want to know the y-intercept. To find the y-intercept, I've got to find f of 0. So I'm going to plug in 0. -2 times 0 minus 1 squared times 0 plus 2. So let's see what kind of number we get here. That's going to be -1 squared, and this is going to be 2. So I'm going to have -2 times 1 times 2, which is going to be -4. Now that's a point that I know. 0, -4. 0, -4. I can graph that point. I want to graph it. So 1, 2, 3, 4. It's right there. Okay. And, oh, did I talk about symmetry? Symmetry, I don't think there's going to be any symmetry here. Now, I could multiply it out, but I'm looking at an x squared, right? And then an x cubed. And then I'm going to have some kind of x squared plus some kind of x most likely. So I highly doubt that it's going to have any symmetry to it. Okay, but I don't think so. I don't spend a lot of time on that. If you know it's going to be even, great. That'll really help. But if you don't, I would just not worry about it. I don't think so. No symmetry. Okay. And then the last thing is turning points. Well, we know the highest degree is 3. Let me scroll back up if I can. Like, this new computer, I'm telling you, it's got all kinds of things here. It does not want to let me scroll. There it goes. Yeah, it was an x cubed. So my turning points, I can have at most 2 turning points. Now, this kind of helps you make a good graph, so you don't get crazy with like putting a bunch of squigglies in your graph or something, and so it's going to be a little bit cleaner. All right. So could I get more points? I could plug in -1. That seems reasonable, maybe. to find more points if I wanted to say, what's f of -1? And I could plug that in. It's going to be -2 times -1 minus 1 squared times -1 plus 2. Now this might not come out to be a nice number. Let's see. Let's see, it doesn't want to scroll for me. -2 squared. I don't know about that. This is going to be 1. So I'm going to get 4 times -2. I'm going to get negative. So it's going down there quite a bit, right? It still fits on my graph paper. So that's the point -1, -8. Okay. Now, why did I choose to find another point? Well, it seemed kind of in the ballpark. So why not, kind of looking at that. I could find more points if I wanted to. Maybe another good one would be f of 2. See what happens there. There's no guarantee that it's going to work out great, but let's see. I think that's what we're getting here. So -2 times 1 squared, which is just going to be 1 times 4. That's also going to be -8, so that's kind of interesting. It's not a symmetric thing. It just happens to work out that way. All right, well, that's, about as many points as I want to try to find. Probably more than that, they're going to be really large or really small. I wouldn't spend too much time finding a lot of points. But I found a couple, probably more than usual. And now I'm just going to graph it as best I can. I know it's starting up and it's going to come down. I know it's crossing at -2. So remember our behavior at the zeros. So it was crossing at -2. So that's what I've got going here. I don't have it drawn really well, but it's crossing. It's coming back up here. It's going to hit that other zero and bounce and come back down. So putting the arrows at the end indicates it's going off like that. Not the best picture, I'll admit that, but too bad. That's what it's doing. These take a little while to graph, but just do your best, and that's what we can hope for. They're a rough sketch. Okay. And I don't have more than 2 turning points. I've got a turning point there and a turning point there. So that's good.